The James Webb Space Telescope has quickly become the most powerful tool ever made to study the universe. It's not just a better version of the Hubble Space Telescope. It's a whole new level in how we can look deep into space. With its huge 6.5-meter gold-coated mirror and advanced infrared instruments, Webb lets us see farther and clearer than ever before. This telescope opens a window into time itself, allowing us to look billions of years into the past, and also forward to new worlds that might support life. Webb isn't just about watching stars and galaxies. It's about changing everything we know about space, time, and even life itself. It was built to answer some of humanity's biggest questions. How did galaxies form and grow? What's inside the atmospheres of planets around other stars? Are we alone in this vast universe? For decades, these questions felt like science fiction. Now, thanks to Webb, they are real scientific goals, and we are starting to get answers. One of Webb's most exciting discoveries is a planet about 120 light-years away, in the constellation Leo. This planet is called K218b, and for the first time, astronomers have found carbon-bearing molecules in its atmosphere. Molecules that on Earth are closely linked to life and organic chemistry. These molecules suggest that K218b might have a vast ocean beneath a hydrogen-rich atmosphere, a huge ocean world that could potentially support life. This is more than just a space discovery. It could change the search for alien life forever. K218b was actually discovered years ago during NASA's K2 mission, which extended the famous Kepler Space Observatory's work of finding Earth-sized planets in habitable zones. Areas around stars where liquid water could exist. What makes K218b special is that it orbits right inside its star's habitable zone, but it's much bigger and heavier than Earth. It's about 8.6 times the mass of Earth and has a radius 2.6 times larger. This puts it in a group called sub-Neptunes, planets larger than Earth but smaller than Neptune. Sub-Neptunes don't exist in our solar system, so they're mysterious and fascinating. Scientists have wondered for years if these planets have thick gas atmospheres or rocky, water-covered surfaces. The James Webb Space Telescope has finally helped solve some of these mysteries. Using its near-infrared spectrograph, NIR spec, Webb studied the starlight passing through K218b's atmosphere as it moved in front of its star. This method is called transit spectroscopy, and it reveals the atmosphere's chemicals by their unique absorption, fingerprints. Webb detected methane, CH, and carbon dioxide, CO, two important carbon-based molecules. These molecules are considered potential biosignatures, signs that life might exist, especially when found in certain ratios and without others like ammonia, which was not detected here. The absence of ammonia makes scientists think K218b isn't just a gas giant but could be a water world, with an ocean covered by a hydrogen-rich atmosphere. This led researchers to suggest K218b might be a Hycean planet, a new theoretical class of worlds with deep oceans under hydrogen atmospheres that might support microbial life. One of the most intriguing findings was the possible detection of dimethyl sulfide, DMS, a molecule produced only by life on Earth, mainly by ocean phytoplankton. DMS is considered a strong biosignature gas. Although the detection of DMS on K218b is still uncertain and needs more proof, it marks a major step forward in exoplanet science. For the first time, we might be close to finding a chemical linked exclusively to biological activity on a planet far beyond our solar system. Scientists remain careful, though. The presence of carbon molecules doesn't guarantee life exists. Volcanic activity or sunlight-driven chemical reactions could also create these gases. But the combination of methane, carbon dioxide, no ammonia, and possible DMS builds a picture that's hard to ignore. Dr. Niku Madhusudan from the University of Cambridge, a lead researcher on the project, explains that while K218b is in the habitable zone, it might not be habitable in the same way Earth is. The high pressures and temperatures under a hydrogen atmosphere could make life very different or even unlikely by our standards. Still, the idea that life might exist in such an alien environment is exciting and pushes us to expand our definition of where life could thrive. What's next for K218b? Webb's next goal is to use its mid-infrared instrument, MIRI, to explore the planet's atmosphere more deeply. MIRI will help reveal the planet's temperature, cloud behavior, weather patterns, and most importantly, confirm whether DMS is really there. If confirmed, this would be the first time a biosignature gas is detected outside our solar system, a historic breakthrough. Even without confirmation, Webb has already transformed exoplanet research. K218b is now the best-studied sub-Neptune in a habitable zone, opening the way for more missions and telescopes to search for life and organic molecules in the universe. But K218b isn't the only place Webb is rewriting our cosmic story. In another astonishing discovery, Webb detected complex organic molecules called polycyclic aromatic hydrocarbons, PAHs, in a distant galaxy named SPTO 41847. PAHs, found on Earth in soot and petroleum, consist of many carbon atoms arranged in rings. What's amazing is that this galaxy formed just 1.5 billion years after the Big Bang, when the universe was only about 10% of its current age. This means that even in the universe's early, chaotic days, complex carbon molecules were already forming. This challenges earlier beliefs that such molecules took billions of years to appear through star explosions and cosmic enrichment. Webb shows these building blocks of life were present and widespread very early on. Even more curious is that these molecules aren't evenly spread across the galaxy. Some areas have many, others very few. Scientists don't yet understand why, but this suggests galactic chemistry is more complex and dynamic than thought. To give perspective, our Milky Way is about 13.6 billion years old, and yet this younger galaxy, SPTO 41847, is already as big as the Milky Way and rich in carbon and oxygen, crucial elements for planets and life. Webb's unprecedented sensitivity makes these discoveries possible. It can detect the faintest light signals from far away and break that light into parts to identify chemicals, revealing secrets about galaxies, stars, and planets. For the first time, we aren't just detecting molecules in distant places. We are mapping them, understanding their origins, and exploring their role in the cosmic puzzle. Whether it's methane on a far-off ocean world or PAHs in a young galaxy, organic chemistry seems common, not rare. This has big implications. If the building blocks of life are everywhere, could life itself be widespread too? Could it emerge under many conditions, not just on Earth like planets, but under hydrogen skies, deep oceans, ice, or places we haven't imagined? We are just starting to seriously ask these questions. Thanks to Webb, we're beginning to get real answers. The James Webb Space Telescope is still early in its mission, but it's already changing how we see the universe. Every new discovery reveals a cosmos that's more complex, more alive, and more full of possibility than we imagined. At Wave's Discovery, we believe these findings aren't just facts, but milestones in humanity's search to understand our place in the universe. As scientists, storytellers, and explorers, we stand at the edge of a new era where the search for life beyond Earth is no longer just a dream, it's a focused scientific journey. Tell us your thoughts in the comments. What do you think about the K218b discovery? Are we closer than ever to finding alien oceans or life? And what do the carbon molecules in ancient galaxies tell us about how life began? If you enjoyed this deep dive into the universe, subscribe to Wave's Discovery, hit the bell icon, and stay tuned for more cosmic journeys. The universe is vast, mysterious, and beautiful, and together, we'll keep uncovering its secrets, one discovery at a time.